Hello friends, welcome to this video. So finally we are going to talk about characteristic polynomial, a really interesting and really important topic for TYBSc, for MSc or any competitive exam in the mathematics. And as a concept of linear algebra, it is really important. Okay? So before starting with the concept, let me just try to make an interest in this concept. Okay, so I have considered a 2 cross 2 matrix A, 1, -1, 2 and 4. I want to talk about this matrix. This matrix are nothing but a linear transformations, correct? So this matrix A is nothing but a linear transformation from R2 to R2, correct? Okay, so I know it will take an element of R2 and send it to an element of R2. So let me just check a map of A of the element 1 comma minus 2. Means I'm trying to check where this 1 comma minus 2 will get mapped inside R2. Let me just try to see. So this is same as 1 minus 1, 2, 4, 1 minus 2, correct? Let us just multiply this simply. This is this into this, right? So it is 1 times 1 plus minus 1 times minus 2 is 2, yani ki 1 plus 2, yani ki it is 3, okay? Then 2 times 1, yani ki 2, and minus 8, 2 minus 8 is minus 6. So I know that A is mapping 1 comma minus 2 to this 3 comma minus 6. Can you see something special in this case? Yes, you can see that my A of 1 comma minus 2 is getting mapped to 3 times 1 comma minus 2. Correct? So what does A did? A just sent this element to the scalar product of it. Correct? He just multiplied that by 3. Does it mean A will send every element to 3 times of it? Means if I consider A of any 2 comma 3, will it be 3 times of 2 comma 3? The answer is no. You can check this, right? Let us just try to see. So it is 1 minus 1, 2, 4, 2, 3. If I just multiply this, let me just check. If I just multiply this, what is the first element? 2 minus 3. It is coming out to be minus 1. No need to check for this, right? So it is not coming out to be 3 times 2, 3. So it is not the case it is doing this same with an every element. But this 1 comma minus 2 was a special element such that it is sending it to the scalar product of it. So this property is actually nothing but taking us close to what is called as a characteristic polynomial, or I will say the characteristic root, or I will say the characteristic vectors. Okay. So this is something that we are interested in. So my question is, can I find out such vectors such that it will get mapped to lambda times of it? So let me just go in detail. Let A be any n cross n matrix. Whatever we have done over here, I want to do same in general. In this case, I gave you this vector, right? 1 comma minus 2, I gave you. But by using this general formula, you also can do this. Okay. So let A be any n cross n matrix. Then I am interested in finding out such x such that x will get mapped to lambda times x, where lambda is any scalars. If my matrix is over R, then it can be R, element of R. It is over C, then it is an element of C. Okay. So first question, I have considered x not equal to 0, because if I consider A into 0, then it is lambda times 0 for all lambda. Correct? So this becomes really general case. Hence we consider x not equal to 0 only. Okay. So I am interested in finding out x and lambda such that my A times x is equal to lambda times x, where this is what? This is nothing but a scalar and this are nothing but the column vectors. And A is nothing but n cross n matrix. Okay. Suppose there exists some x and lambda. Then what will happen? It will satisfy this equation. That means it will satisfy my Ax minus lambda x is equal to 0. Correct? Okay. So after this, let me just do something special. What I will do, I'll just take A minus lambda times in, and I'll just take this x common. It is equal to 0. You can just distribute this x inside and you will get the previous equation. Right? This means what? This matrix times x giving me answer as 0. Correct? Does this matrix equal to 0? This matrix. Okay. suppose if I give you b times x is equal to 0 and this matrix, can you conclude something about this matrix? Yes, I know my x is not equal to 0. Means my b is some matrix such that there exists a non-zero x such that after multiplying I am getting my answer equal to 0. When is it possible? Is it possible when my b is invertible? Let me just go in detail again. Suppose my b into x is equal to 0 and my x is not equal to 0. Okay, this is my assumptions. If my b is invertible, then my determinant of b is not equal to 0. Definitely this is the case. I want to say my b is, sorry, if my b is invertible, then determinant of b is not equal to 0. If b is invertible, what I will do? I will multiply b inverse on both the sides. So it is b inverse b x is equal to b inverse 0. B inverse, this is nothing but identity into x is equal to 0. X is equal to 0. Means if I have these two conditions together, then my b cannot be invertible. That means my determinant of b cannot be equal to 0. That means it must be equal to 0. Trying to getting it right? What I want to say is, if I have these two conditions together, then the matrix B cannot be an invertible matrix. The same conditions are over here also. I have A minus lambda in as one matrix times x is equal to 0 and my x is not equal to 0, implies my A minus lambda in is a matrix is not invertible. Correct? Since if it is invertible, then my value of x will be 0. If it is not invertible, then my determinant of A minus lambda in must be equal to 0. Okay, now if you observe this, this is nothing but which is called as a characteristic polynomial. Okay, so this is nothing but what is called as a characteristic polynomial. Why we call it as a characteristic polynomial? Because this equation will give you a polynomial in terms of lambda, and after finding out root of that polynomial, you will get distinct value of lambda. By using that lambdas, you can find out distinct values of x also. So for now, you will write the definition of characteristic polynomial for a matrix A is equal to determinant of A minus lambda in. Okay. And what is characteristic equation? Characteristic equation means equal to 0. Correct? Polynomials mean this much only. Equation means this equal to 0. Okay. So this is nothing but the characteristic polynomial. Let me just try to solve this once. Okay. So I will consider the same example. A is equal to, what was the example that we considered previously? 1, -1, 2 and 4. Okay. 1, -1, 2 and 4. So the characteristic polynomial of A is determinant of A minus lambda i2. Correct? So this is same as determinant of A minus lambda i2. That is same as determinant of 1 -1 2 4 minus lambda times identity 0 0 0 lambda. Correct? Okay. So that is same as determinant of 1 minus lambda, right? -1 0, it is -1. Over here it is 2. 4 minus lambda. 4 minus lambda. So this is nothing but equal to what? Let me just find out the determinant easily. It is 1 minus lambda times 4 minus lambda minus of -2, right? It is +2. That is same as what? That is same as 4. Then it is same as what? It is same as this is 4. This is nothing but minus lambda. This is -5 lambda plus lambda square plus 2, which can be written as lambda square minus 5 lambda plus 6. Correct? Simple. Now, how can you simplify this? This is really trivial, right? So it is lambda minus 3 and lambda minus 2. Correct? So if you observe, I have used the matrix and I have used this 3 over here. So by making this concept, I have solved that characteristic polynomial and find out this 3. Now let me just find out this from this. Okay. So from 3, let me just find out that matrix, that 1 comma -2. So I know 3 is nothing but the characteristic root. Okay, this is called as a characteristic root. The roots of the characteristic polynomial are called as a characteristic roots or called as a eigenvalues. Okay, in the next video I will go in detail about definition, but in this video I just want to give you an introduction. So let us just go. So I want a times x to be equal to, root is 3, right? 3 times x. So I will now find out x, value of x. So it is 1 minus 1 2 4 xy is equal to 3x 3y, correct? Let me just solve this matrix over here. So it is x minus y, over here it is 2x plus 4y, correct? That means what equation I get is, I get 3x is equal to x minus y, 3y is equal to 2x plus 4y, right? And both of them after simplifying will give you only one equation. What is that? That is same as over here if I take it like this. Okay, so it is 2x plus y equal to 0. This is nothing but both of them will give you after simplifying, correct? So now how do I find out that 1 comma minus 2? These are nothing but solution of this, correct? So this is nothing but what was going behind the question. I know these are lots of bouncers, but I just wanted to share what is a characteristic polynomial. Characteristic polynomial of any matrix is nothing but determinant of a minus lambda in. Why we are interested? Because after find out root of this characteristic polynomial, we get the values of lambda, by using which we can find out which element will get multiplied as in its image, correct? Okay. Definitely the question arises, why we are interested if some element are getting mapped like multiplying by the scale up and down. This is nothing but a small application of the characteristic polynomial. When you go higher level, it means in unit 2 and unit 3, you will understand the importance of this characteristic polynomial. They are really interesting. But initially, if I just want to introduce, I will introduce these are nothing but those scalars which will get multiplied to a vector after applying the image, after applying that matrix A. Okay, so this is about the first video. In the next video I will giving you an exercise question to solve, but for now I think it is enough to introduce what is a characteristic polynomial. Okay, I hope you guys have understood. For any difficulty and doubt, please write in the comment box, give me your review in the comment box. Okay, thank you guys.